Okay, so in this video we're going to be using the properties of the Laplace Transform to solve initial value problems. The really only new material in this section is these three formulas, which were actually in our section 7.3 homework. We just haven't used them up until now. These properties state that y double prime is equal to s squared y of s minus sy at 0 minus y prime at 0. Y prime is equal to s times y of s minus y of 0, and y is equal to y of s. So what does this mean to us? Well, let's use it in a problem. So in this problem here, right here, this is given to us. This is one of the first questions in this section. We have y double prime minus 12y prime plus 52y is equal to 80e to the 6t, where y at 0 equals 5 and y prime at 0 equals 34. The first thing we need to do is find the Laplace transform of all the terms. So y double prime is equal to s squared y of s minus s times y of 0. Well, y of 0 is 5, so we have negative 5x s minus 34, or y prime at 0, which is 34. Then we have to find the Laplace transform of negative 12y prime. Well, it's just going to be negative 12 multiplied by the Laplace transform of y prime. So we end up with negative 12s y of s. And since it's a negative, we'll have a double negative plus 60, because y of 0 is equal to 5. And 5 times 12 is 60. Finally, we'll have plus 52 times the Laplace transform of y is equal to 52 y of s. And that's all equal to 80 over s minus 6, because the Laplace transform of 80e to the 6t is 80 over s minus 6. So the next thing we want to do is we want to factor out the y of s in any terms containing y of s on this side, while simultaneously adding over any terms that don't have y of s to this side. Just algebraic manipulation to solve for y of s. So when we divide by s squared minus 12s plus 52, we end up with y of s is equal to 80 over s minus 6, s squared minus 12s plus 52, plus 5s minus 26, s squared minus 12s plus 52. And technically, this whole term is in parentheses. Okay, so now what? Well, moving on, we're going to continue to simplify this by finding a common denominator. So here, we can multiply both the top and the bottom by s minus 6, and this will become one big fraction. So we do that, and we get 80 plus 5s times s minus 6 minus 26 times s minus 6. We distribute and simplify, and we get 5s squared minus 56s plus 236 over s minus 6 times s squared minus 12s plus 52. And then we set up the partial fraction here as a over s minus 6. But remember, we actually complete the square here. And when we complete the square, we have to use that variation of partial fractions, where it's b times this, the square root of this term, plus c times the square root of this term on the top over the whole thing on the bottom. Again, that's the variation of parameter, or sorry, not variation of parameters, partial fraction kind of deviation that we did in section 7.3. Okay, so now we distribute this denominator, we do our standard partial fraction procedure, and we solve for a, b, and c. When we plug in 6 for s, this term will cancel, and we'll be left with 16a, and when you plug 6 in here, you're left with 80. 80 divided by 16 is a equals 5. When a equals 5, and we group the s squared, so we have an s squared here, so a. We have a b s squared here, when we distribute that s minus 6, so we get a plus b is equal to 5. And that means b is equal to 0 when we plug in 5 for a. And when we group the s's, so we distribute this term to all this, and we find that we are left with negative 12bs plus 4cs minus 12a. Of course, we just disregard the s's, just, again, standard partial fraction procedure. We find that this is all equal to negative 56, and when we plug in b equals 0 and a equals 5, we're left with c equals 1. So, finally, we have y over s is equal to 5 over s minus 6 plus 4 over s minus 6 squared plus 16. To find the initial value, we have to take the inverse Laplace transform of this, so we can put it in a variable of t. Doing that, this isn't too tough. With a little cheat sheet of Laplace transforms, we end up with 5e to the 6t plus e to the 6t sine 4t. And that will be the initial value problem when given this expression. I hope this helped.